One of the important tools that we're going to be using throughout this course is something that we refer to as dimensional analysis. In some ways, the term dimensional analysis is just kind of a fancy term for the idea of unit conversions. But basically, this gives us a step-by-step process which we can use in any situation to convert from any unit that we start with, no matter how unusual, to whatever our desired unit is. And what it's largely based on, if you think about how numbers work and how we can cancel numbers, in a fraction. For example, if we had a fraction x squared over x, we know that's the same as saying x times x over x. And so we know that we can cancel because we have a unit that's the same on top and bottom. And we end up with just what's left over. Well, just like with numbers, units can also cancel. So for example, if we had grams times milliliters over milliliters, just like in the example above, our milliliters can cancel and we'd be left with just grams. So as long as we have a relationship to convert our two units, one to the other, then that's going to allow us to have a process by which we can get to our desired unit. So to do that, we use conversion factors. And conversion factors could be any two quantities that are equal to convert in between units. And they're set up as a fraction. 1 meter, for example, is 100 centimeters. And we could have it this way, or if we were converting the other direction, we can have 100 centimeters over 1 meter. And again, this could be any unit that we know that's equivalent. 1,000 milliliters over 1 liter. 1 kilogram over 1,000 grams. These are all metric examples, but we could use, non-metric units. And it's the same argument. 5,280 feet is 1 mile, and so on. We can multiply any, number that we have by one of these conversion factors because these quantities, even though they're different units, are all equal. And because they're equal, the value of the conversion factor is 1. So 1 meter is the same as 100 centimeters. So if we multiply by that conversion factor, it is the same thing as multiplying by 1. In addition to that, unit conversions, these conversion factors don't have an impact on our significant figures because especially, in the case of the metric conversion factors, but, any conversion factor, we just assume that these are exact values and therefore they don't affect significant figures. So the process we go through, find the unit that we're starting with, what's the desired unit, and how do we get there? Sometimes we can get there in a single step, but sometimes we may have to go through, multiple steps to get to where we need to be. So for example, let's say that we wanted to convert 1 kilometer into inches. Now, the first thing you want to consider when you're doing one of these problems, it's always a good idea to think about whether your answer makes sense. Is it logical? And I'll explain what that means when we get to the end of this example. So there's any number of different routes that we could take here, all of which will get us to the same answer. For example, we could go from kilometers to miles, miles to feet, feet to inches. We could go from kilometers to meters, meters to centimeters, centimeters to inches. And there's many other paths you could take as well. Any of them will get you to the exact same answer. But let's go through and do both of these. So 1 kilometer, we're going to go to meters. So we know that there's 1,000 meters in a kilometer. And we need to know, do we put meters on top and kilometers on the bottom? Or do we put kilometers on top and meters on the bottom? But our important thing we want is that our units will cancel. And you can see here, if we put kilometers on the bottom, then kilometers cancel and we're left with meters. So 1,000 meters is 1 kilometer. And for this first example, I'm going to give you the math at each step along the way. So that's 1,000 meters. Then we're going to go from meters to centimeters. Now in the previous example, or the previous step, we had meters on top because we were going to meters. But now we want to get rid of meters. So we need meters on bottom, centimeters on top. So 100 centimeters is 1 meter. And so we have 100,000 centimeters. Finally, we can take our 100,000 centimeters and convert to inches. Now we put centimeters on the bottom, inches on top. 1 inch is 2.54 centimeters. And we do that, we should get, because we started with 2 significant figures, so we're going to round to 2 significant figures here, approximately 39,000 inches. Now, as I said, you don't have to, you could have used a different set of conversions here. You could have gone kilometers to miles, miles to feet, feet to inches. So maybe take a moment and try that. Our conversions, 0.621 miles is 1 kilometer. There's 5,280 feet in 1 mile. And then the one that you probably know, 12 inches to a foot. Now also just recall, if you're in my course, that conversion factors like the meters to kilometers and the centimeters to meters, those are conversions you need to know, that you'd need to know without looking them up. you'd be responsible for those on an exam. But conversions like these non-metric conversions, those, if you needed them on an exam, I will provide those for you. So I'm going to leave, this would be a good point for you to pause the video and do this 1 kilometer to inches using the second set of conditions that I gave you, kilometers to miles, miles to feet, feet to inches. So go ahead and try that, and then you can unpause and we'll go through the solution. So now, assuming that you've gone through this, 1 kilometer, 0.621 miles to 1 kilometer. Again, we're going to put kilometers on the bottom here because we want that unit to cancel. What I'm going to do here, though, instead of writing out our answer after each step, we're just going to put each of our conversion factors sequentially. So now we want to go from miles to feet. So we use our 5,280 feet is 1 mile. Again, putting miles on the bottom. So now miles will cancel out. We're left with feet. And finally, in our last step, we'll convert from feet to inches. Now putting feet on the bottom so that it cancels. And once we go through the math, not surprisingly, we get the exact same answer as on the previous calculation. So let's do a couple more examples. And then there's a whole sheet of practice problems for you to try. One thing we want to say about when we're dealing with metric conversions, metric conversions are essentially just moving the decimal point around because all of our metric conversions are based on factors of 10. So if we had 5 kilometers and we wanted to go to meters, we know that there's 1,000 meters, or sometimes it's even easier to say 10 to the third meters is 1 kilometer. And then you can just say 5 times 10 to the third meters. You could then go further and go to millimeters. It's 1,000 millimeters, or again, 10 to the third millimeters in 1 meter. And so again, we're just changing our factor of 10 here to reflect that. So 5 times 10 to the 6 millimeters. So the one spot where this can get a little bit more complicated is if we're dealing with a more complicated type of unit. Say something that we're dealing with, how fast something is moving. And the reason I say that can get more complicated is that's a unit that has 2 pieces to it. So meters per second, miles per hour. And we'd have to convert each of these units separately. So say we wanted to convert from meters per second, which is a very common metric unit for speed, to miles per hour, which is a very common non-metric unit for speed. So that means we actually have two sets of conversions. We're going to convert meters into miles and seconds into hours. But in addition to that, we also have to worry about where the units are. So let's take a look at that. And so as a calculation here, we're going to start with 3 times 10 to the 8 meters per second. That's a number we might be familiar with. That's essentially the speed of light. So let's start with our distance. We're going to convert from meters into miles. So meters is on top. We want to get rid of meters, so we need to put meters on the bottom. I'm going to put kilometers on top. And the reason I'm going to kilometers here is just because I know the conversion from meters to kilometers. So it becomes just, I'm sorry, from kilometers to miles. So it just becomes for me sort of the easiest route to use. So 1 kilometer is 1,000 meters. And if we now stop and calculate that step out, and this is not something you would need to do on a problem like this. I'm just trying to go very, very stepwise so you can see where we're going. So that gives us 3 times 10 to the 5th kilometers per second. I'm going to take our 3.3 times 10 to the 5th kilometers per second, and we're going to convert that into miles. So miles will go on top, kilometers on the bottom. 0.621 miles is 1 kilometer. So we get 1.86 times 10 to the 5th miles per second. And again, in both of these cases, as we've been doing, we wanted to cancel meters, so we put meters on the bottom. The next step, we wanted to cancel kilometers, so we put kilometers on the bottom. Finally, we need to convert 1.86 times 10 to the 5th miles per second into hours. Now, you can do this as one step, you can do it as two. Doesn't matter if you don't know that or don't remember that it's exactly 3,600 seconds to the hour. You can do this as two steps, 60 seconds to the minute, 60 minutes to the hour. What's different about this step, so every step we've done up until this point, we've put the unit we wanted to get rid of on the bottom so it would cancel. But here, the unit that we want to get rid of, seconds, is already on the bottom. So if we want to get rid of that, if we want that to cancel out, we're going to need to put it on top. And then the unit we're trying to get to, which is hours, that ends up on the bottom. So it's not always as simple as put the unit you're trying to get rid of on the bottom, because if that unit's already there, then that won't cancel it out. So you need to put it in the opposite. If the unit you're trying to get rid of is already in the numerator, then you put it in the denominator to get rid of it. If it's already in the denominator, then you put it in the numerator. So 3,600 seconds is 1 hour. And that means we have 6.71 times 10 to the 8th miles per hour. All right, final thing before you start working on some practice problems related to unit conversions and dimensional analysis is I want to mention density. Density is the relationship between mass and volume. Now, how do we remember density? The equation is relatively simple. Density, which we denote by this lowercase rho, is equal to mass over volume. But if you have any trouble remembering that, I found that sometimes this can be helpful. So this is a clip from the 80s movie Back to the Future, and we'll just see what George has to say here.
Lou, give me a milk. Chocolate. Sherry Coke. Lorraine, my density has brought me to you.
What?
Oh, what I meant to say was,
Wait a minute. Don't I know you from somewhere?
yes, I'm George McFly. I'm your density.
So just to repeat what I was saying, since I forgot to unmute, if we think about what George was doing there, he unfortunately kept getting density and destiny mixed up. So if we think if we use that same association and we look at density and we think of density by this heart, we draw a line through it, and you can see the heart when we draw a line through it kind of looks like mass over volume. So the final thing we want to say about density is that density is an intensive property. So if you go way back to the list of different types of properties, intensive means that it's a property that does not depend on the quantity that we have present. But that doesn't mean density is always a constant. Density can and often is dependent on temperature. In other words, we get different densities for a substance at different temperatures. And this is something that you're familiar with. If you think about, just something like ice, the fact is we all know that ice floats on water. They're both, or on liquid water, they're both the same molecule. They're water, but ice has a different density, and that's why we see that it floats. So at this point, this is the end of our sort of introductory unit, our first chapter in general chemistry. And at this point, definitely want to do some practice problems. We've got, for my class, I've got a set of practice problems that you can find posted within the course, and we'll have a video after this where we go through the solutions to all of those problems.